The pool with the window, and the pool is 5 meters deep. On the window is on one of its vertical walls, and we're gonna find the force. This is about the force of the pressure against the surface. Uh, or we find the force on the window that is a square, that's the shape of the window, 2 meters on a side with a lower edge on the bottom of the pool. So first of all, when we draw the figure um, for the pool, think about the wall like 5 meters deep. Okay. And okay, 5 meters. And then we have the window. That's the base. Sit on the bottom of the pool with the shape, like square shape. Does it make sense? Okay. And the dimension of the window is 2 by 2. So 2 here and 2 here. The question asks you to find the force on the window. So we target this area. Excuse me. Just the force on the window. Okay. Our target is the square shape here. So we pretend like we have one slab of water. Since the pool is full, right? The 5 meters deep. So we pretend like we have one layer of water. Try to change the color here. Excuse me. Okay. Before we get too far, remember the first step. We're gonna draw the axis of reference. And since this is looks like the symmetrical one, so we're gonna draw the y-axis just right in the middle of the figure. So this is the y-axis. Okay, and the origin is on the bottom of the pool. So right there, so that's the 0, 0 point. And at the position of that slab of water that we consider, that's a position y. Okay, and then from the position, I'm going to make a list again. The position is the y. So then the thickness of the slab or one slab of water is delta y or dy. And then what else that we know of? We're gonna find the interval of integration. Since the position y is located within the window, dimension of the window is 2 by 2, and the origin is on the bottom. The height of the window is 2. So y will be between 0 and 2. Okay. From the formula to find the total force. So the total force. Or the F, gonna be the integral. The rho, the G. Rho is the density of the water that we always use 1,000. And the G is the gravity constant, the 9.8. And multiply by the width, multiply by the depth, and multiply by the thickness. Recall how to form this formula is from F equals MA or mg, and then the m is from the rho or the density is m over v, and we rearrange the term to be like m equals rho times v, and v is the volume. If you recall, the volume is from the cross-sectional area multiplied by the thickness. That's why the formula formed. Okay, the width, the depth, the thickness. So with this one, we know the thickness, which is the delta y or dy. The width, so we're gonna look at the width of the layer that we consider. We, for the examples on the notes, so we do the x to the left and x to the right. Since we do not have the clear dimensions for the shapes for the objects that we have in the problem on the notes, but this one in the window is 2 by 2. We know exactly the dimension. So then the width of this layer gonna be 2. So I'm gonna put the note here. So the width gonna be 2. If you think about x to the left, x to the right, so that means at the beginning, at the middle is 0. So go to the left 1, go to the right 1. So x equals 1 on the left, x equals -1 on the right. So the total gonna be 2 anyway. Okay. The example that you see on the note is it contains the variable. So that's why you have to put together to find the relationship of the x and y and then bring it into the integrand. But for this one, we have the constant number. Now we know the width, which is 2, and the thickness dy. About the depth, so we have to think about the whole pool. The whole pool is 5 meter deep, and the pressure is on the bottom, which is just against the surface of the window. To consider the depth, you have to consider the whole pool based on the layer that you consider, that you work on or you reference on. uh, so for this one, think about the depth from the top of the pool to that layer. The measurement from the top of the pool to the layer, that is the depth. And the top of the pool, the maximum height of the water is 5. And up until that position is y. So we have the depth is 5 minus y. After that, you put them all into the integrand and work the normal way as you always do. Would that help? So it's going to be integral from 0 to 2, the rho, the g, put the note here, the rho equals 1,000, and then the g equals 9.8. Okay. Rho g, and the width is 2, the depth is 5 minus y, and the thickness is dy, and keep going for the rest of them.